So today we would start the sequences. So the first question, in fact, is what is a sequence? Do you have some idea what a sequence is?
Like a pattern.
Yeah, like a pattern. And we say a sequence is a set of items belonging in a certain order. So first thing is there is, so I just write. So there is first some certain order, certain order. And if you know that order, you can tell what is going to be the next
Next term.
term. Yeah. So sequence is a set of items belonging in certain order as per some rule. So there, it has to have some rule actually on the basis of
So it's
which
like a function.
you can say, yeah, you can say a function. But the interesting thing is, which you would understand, that it gives you the terms in the rule. Mm, terms in the sequence. So just bear with me 2-3 minutes and then we would be. So if you know sufficient items, you can know the rule. And if you know the rule, then you can determine the next items. Yeah.
Yep.
So first of all, let me write a very simple uh, series of numbers. Let's say we start from 1, 3, 5, 7, 9, and so forth, so on, right?
Yep.
So we normally say this thing as it's a sequence. Do you know how this sequence is? Can you tell me the next term after 9?
11.
Yeah, 11. So we understand it has a sequence, and the sequence,
Yep.
the rule would be, so normally what we should do say, we write this thing as T1. T1 means term 1, right?
Term 1. Yep.
Okay. And if I ask you from this sequence, what is T4? Can you tell me here what is T4?
7.
Yes, 7. So normally we write this thing as a subscript, right? We do not write like this T4. No, we write like T subscript 4. Do you understand that?
Yep.
Because if we write T4, it may be in algebra taken as T times 4 or T multiplied by 4. Yeah, if T is a variable. So we would not write like this, we would write like this. Okay. And then if you write like this, you can say there is something else which is says Tn. What is meant by Tn? It means we where n is a variable. Where n is a variable. What does it means? It means you can give any value to n. For example, in our example which we are doing now, if we put n is equal to 3, so can you tell me what is T3 from the above sequence?
T3 is 5.
Very nice. And if you see what is T3 is 5, and if we have seen what is T5 actually,
9.
very nice. This brings us to, we have seen that there is a rule. Can we find the rule here? Can you tell me, do you see some rule here for this sequence?
Uh, Tn Tn plus 1 equals Tn. So like T and the number below, the term number.
Yeah,
So if equals T Tn plus 2.
very nice, very nice. So we can write the rules like this for this. Tn plus 1, which is in subscript, is Tn plus 2. So it means we are saying that the next term is as the previous term plus 2. Good?
Yep.
Okay. In this case, we can also say this thing as normally. This thing is called a arithmetic sequence. What is an arithmetic sequence? Arithmetic sequence. Let me write it first and then I would explain. Normally, a sequence where the next term is found by adding some constant. So normally general formula. So we will write general of arithmetic sequence. It's also called arithmetic progression. General formula of arithmetic sequence. I'm just writing AS, right?
Yep.
It's also called, as I said, arithmetic progression. So I just write that also. Arithmetic progression. It's the same thing. It has two names, arithmetic progression. If you see the general formula says of arithmetic sequence, Tn plus 1 is equal to Tn plus D, where D is a difference. It can be positive or negative, right? What
Yep.
does it mean if I write something like this? Yeah. And if we know the first term, we can write the full sequence. Let me see. If I give you a question example, let's see one example. Uh, the example says the arithmetic sequence has a formula Tn plus 1 is equal to Tn plus 5. And, and we are given, and T1 is equal to 7. Can you help me to write this sequence?
Um. So
The first term is,
first term is uh 5.
no, it's given. Read.
Oh, 7.
Yeah, T1 is 7. So we would write 7. What would be next term?
Uh, 12.
Yeah, 12. Good. Then,
Then 17.
yeah, 17. And then 22 and so on, right?
Yep.
So this general formula of the arithmetic sequence is also called a recursive formula. It is also called
Recursive.
recursive. What is meant by recursive?
It's repeating
Yeah,
in
it's
a
repeating. Yeah,
const.
because the next term to know for example, here, to know 22, you had to know 17. To know 17, you have to know 12. For knowing 12, you have to know 7 because you are adding a constant difference. Here, the difference is 5, right?
Yep.
Does it make sense to you? Does it make sense to you?
Yep.
Then there is something very interesting. What is D actually here, which is here? Do you know what is D?
Uh, D is five. D is 5.
No.
The constant.
Yeah.
Uh,
Normally the D is the difference between two consecutive terms. Do you understand this? For
yep.
example, in case 22 minus 17 is 5. 17 minus 12 is 5. Because in some of the question, they may put the question in a form that they don't give you D. Rather, they give you two terms, and then you will have to find what is D. Does it make sense to you? Or
Yep.
no? So D is the difference between any two consecutive terms, right?
Yep.
Okay. I I try to be just. It's not necessary that that the sequence is always arithmetic sequence. It can be another form of the sequence, right? It's not necessary that every sequence is like what we say is okay. So if we see there it's a very interesting thing also. Let's say we make a sequence and the common difference is 1 and we are starting from 1. This is another example, right? So what I'm saying is T1 is 1 and D is 1. Can you help me to write the sequence, please?
Uh, Tn plus 1 equals to Tn plus 1.
No, Tn plus 1, not n plus 1. It means Tn plus 1, the previous term is actually, the next term is equal to the previous term plus 1. Do you see this or no?
Yep.
So Tn plus 1 is equal to Tn plus 1. Can you help me to write this sequence?
So it's gonna be term 1 is gonna be 1, and then it's gonna be 2, 3, 4, 5.
Very nice, very nice, very nice. Let's draw it for a change. So I would say, what is T1? Let me
1.
make 1, 2. So this is 1, and then we have then 2, then we have 3, then we have 4. If you see, what is this thing?
It's a linear equation.
Yeah, it's a linear equation. That's very interesting. So actually, if you see, we had a linear equation has a form y is equal to mx plus c. Yeah,
Yep.
and what we have now, Tn plus 1 is equal to Tn plus d. So what does it mean? What is d actually, if you compare it?
It's a
It
rate of change.
no, 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 no. Yeah, yeah, yeah. So if you see Tn plus 1, so this like a d, so that's the rate of change, right? So if I plot this, so rise over run, so this was rise over run was here in this case 1. Yeah, if I write the equation of this line, because so it would be y is equal to 1, and if it is x plus 0, this implies y is equal to x. Yeah,
Yep.
okay. So it is arithmetic progression is like a linear equation. We would talk about it later also. Okay, so now we move to the second part and we try to see how it's not necessary that let me ask you one question, a little tricky, Magar, but if I write like this, an example, it is a sequence 13, 18, 23, 13, 18, 23, 28, and so on. Can you tell me that it is arithmetic progression or not? Is arithmetic progression or not?
Yes, because it's increasing by a constant,
And what is that constant?
5.
Very nice, very nice. Okay, if I give another question, example, it's 90, 79, 68, 57, 46, 35. Is it a arithmetic progression?
Um, yep. It's decreasing by 11.
So you would see, for example, here the difference is 90 minus 79 is actually 11, 79 minus is 11, 68 minus. So for arithmetic progression, the first difference should be constant. Do you understand that?
Yep.
Okay, good. So it means it is. So if I just can you help me to write the general rule, recursive rule for this third example, the previous one, 13, 18. So I just write it in a blue.
Uh,
So
Tn
Tn
plus
plus 1.
1 equals T.
Yeah, say again, please. Tn plus 1 is?
Tn plus 1 equals Tn plus 5.
Yes, very nice. And what about this one? Tn plus 1 is equal
Tn
to,
plus 1, Tn minus 11.
yeah, minus 11. So actually it's the same formula because we said Tn plus 1 is equal to Tn plus d. Here d is minus 11. So if I write in this form, this would become Tn plus 1 is equal to Tn plus and then in the bracket minus 11 because d is minus and this will become Tn minus 11. Make sense?
Yep.
Okay, good. So this is something. As I said, it's not normally that you get all sequences arithmetic. Let's take an example. Let's say we have a sequence which is defined by this thing. T, and again, I am changing it a little due to certain reason, is 3Tn minus 1 minus 2 and T1 is equal to 5. Can you help me writing this sequence, please?
It will be 5 and then
Yeah, okay, 5. Then
the one before that will be 13.
after, not before.
Oh, since it's Tn minus 1.
Actually, you see, it is. I said I am making it a little difficult. It's the same thing. It says because it's the same way of writing, but with a different meaning. What does it mean? If you look at this, uh, it says. Let me take a highlighter. Maybe it says Tn. That is 3 times of the previous term. Tn minus 1 means the previous term from the Tn. It is another way of writing. We would write this equation in both form. The way we have been writing, I deliberately put it in a different manner. If can you read this? Can you read this? What does it mean? Present term. Tn means present term is 3 times the previous term minus 2. Do you see this or no?
Yep.
So it means we are given T1. What would be T2 if I put like this? T2, oh sorry, it's highlighter still. If I write like from this equation, so T2 is equal to what? 3 times what?
3 times T, the original term.
Look at here. Actually, what we are doing, we have replaced this n by n is equal to what? Because if we are making it T2, what is n equal to then?
N is equals to T2.
No, no, no. Only we are talking about only n, not t. What is
Oh,
the value of
2.
t? 2. Yeah.
Yep.
If it is 2, what would be Tn minus 1 equal to then?
What, term 1?
No, you would say because you have put 2. So 2 minus 1 is 1
1.
and then minus 2. Do you understand this?
Yep.
Okay. I would ask you one more question so that if the same way, can you tell me what is T6 for this sequence?
Uh, T6 will be equals to
Again, here n is replaced with what number?
6.
Then is 3 and then is T subscript n minus 1. What is n put there? Because we put n equal to 6. So 6 minus 1 is?
5.
So we would say 5 minus 2. Does it make sense to you now?
Yep.
Okay, let me ask another question so that we are. What would be T14 in this sequence?
T14 equals to 3T 13 minus 2.
Yeah, good. So does it make sense to you now?
Yep.
Yeah. If I write the same term which we have in another form, Tn plus 1, can you help me to write the same rule? It is the same rule for the sequence, but now we are making it instead of nn plus 1. What should I write now? Is equal to
Uh,
3
so
times.
3 times Tn
Yeah,
minus 2.
very nice, very nice. It's the same thing. It's the same rule. So this will give you the same sequence. But sometimes you may come across a rule written like this, and sometimes you may come across a rule written like this. But they both are the same. They are same for the same sequence. Does it make sense to you?
Yep.
Okay, so let's write the sequence now. So first term we are given is 5. What would be the next term?
Uh, next term would be 13.
Very nice, 13, because 5 times 3 is 15, 15 minus 2 is 13. Then next term,
Term 3 would equals to
you can use a calculator.
7.
You can use a calculator.
Yep. Term 3 would equal to 7.
No, it 3 times 13 is 3 times
Oh,
13 is 39. 39 minus 2 is 37, not 7, rather 37.
uh,
Yes or no?
yep.
Okay, what would be the next term then?
Uh, 37 times 3. So it will be 1, 1, 1
And then is,
minus 2.
yeah,
So 109.
yeah, very nice. It is 109. And similarly, if you do 3 times 109 minus 2, it would be 325 with the calculator, right?
Yep.
And so forth, so on, right? And if you look at here now, what is the difference between 13 and 5? The difference is?
8.
Yeah. What about 13 and 37? The difference is?
24.
Yeah. What about this difference? It is 72. And this difference is actually 216. So this sequence is not at all an arithmetic sequence.
Okay.
Why? Because the difference is not constant. So it is not an arithmetic constant. This is not an arithmetic sequence. Does it make sense to you?
Yep.
Good, very good. So for arithmetic sequence, but as I said, there could be other type of sequence, and this is an example where it is not an arithmetic sequence, but we are able to find that. Okay, um, you can do it in your class pad also. So, but I would say uh, you can use make sequence, and you must learn how to do it on your class pad because it would save you time. So let's revise what we have done up till now, and then I would move to the next topic. But before going there, I would say what we have learned up till now. So we started with the sequence. Sequence is a certain order as per some rule, and if you know the rule and you know the initial term, you can define the whole term. It has many types of the applications. It's actually why it's because it's a linear equation as we see. So the arithmetic sequence is our general formula is Tn plus 1 is equal to Tn plus D. Can you help me to write it in another form? If I say this same formula can be written in another form, that is Tn. So Tn is equal to what? Now we are instead of Tn plus 1, we are writing Tn.
Tn. And then Tn minus 1.
Yeah, plus D. Don't forget to write
Oh,
D.
yeah.
So this is the same thing. Because here in the first sequence, which I just make it with a red, it means the next term is previous term plus next term is present term plus the D. While here it says the present term is previous term plus the D. It's the same. Here we are saying the next term. Here we are saying the present term. Does it make sense?
Yep.
Okay. Now we have said that this is a line equation. So arithmetic progression is actually like a um, linear equation or a line. And then we said it's not necessary that every sequence is arithmetic progression or as arithmetic sequence. To see if it is arithmetic progression, you would find the difference between the two consecutive terms, and it should remain constant in the sequence if it is a arithmetic sequence. All good
Yep.
up till now? Okay. So now we move to the next part or the next topic. The next topic is called a geometric sequence or a geometric progression, right? So the next is, let me write it, geometric sequence, geometric sequence, or it is also called geometric progression, geometric. So it's a little different from the arithmetic sequence. What is the difference? Let me first write a sequence and I would ask you to tell me how this is. There is a 5, there is a 15, there is a 45, 135, and so forth, so on. Do you see some, so the first term is, what is T1 here?
5.
Okay. And what you see, how we are finding the next terms?
Multiplying term 1 by 3.
Yeah. So, so if you see here, and let me just rub it because I need this. If you divide next term by previous term, what is the result? 15 divided by 5 is
15 divided by 5 is 3.
yeah. What is 45 divided by 3? 15. The next term
3.
divided. Yeah, and 1, so it is also 3. So I'm saying 15 divided by 5 is 3. Here we say 45, and here I put a comma. 45 divided by 15 is equal to 3, and here we say 135 divided by 45 is 3. So here we see a sequence, and we can write similar to the arithmetic progression a rule. The rule says Tn plus 1, the next term, is previous term multiplied by a ratio. And what is the ratio in this case, in this example which we just did?
3.
Yeah, 3. So this is R. R is. So here instead of, so here the progression is this. So instead of a constant being added, now the term is being multiplied by a number. Yeah. And here also you should know with T1 is equal to A. A means the first term you should know. Yeah. And again, this A can be a division. It can be less than 1 or more than 1, right? Can you help me to write a rule for rule for one of the example? I say, let's say the sequence is 3, comma 6, comma 9. I'm sorry, not 9. 3,
12.
12, yeah. 12 or 24, 40.
T1 plus 1 equals
T,
T.
so what is,
Tn plus 1
yeah,
equals Tn 2Tn.
2tn. Yeah, and you have always to write.
plus D.
And no, no, not G.
Oh.
T1, where T1 is 3, because you would, for defining the whole sequence, you have to know the term 1, and then you would start writing the whole term. Does it make sense to you or no?
Yep.
Okay, if it is like this, let's do another example. And we do another example now. So another example. And here, I deliberately take an example which is where the ratio would become less than. Can you help me to write the sequence?
Tn equals Tn plus 1.
Okay,
Uh,
say again, I would write it as you say.
Tn equals Tn plus 1 times uh, a third.
Sorry?
No, times 2/3.
2/3. Like this? Okay,
Yeah.
this equation has something inherently wrong, this rule, because what it says, to know the present term, you have to know the future term. It's not possible. Do you see this? If I say,
Oh,
if I,
Tn plus 1 equals Tn.
so oh yeah, you have quickly. So it is, let me rub then. Let me rub it again. And can you help me again to write
Tn plus 1
Tn plus 1
equals Tn
Tn.
times 2/3.
Okay, I just say 2/3 from here, right?
Yep.
So how you find 2/3 if you put 96 divided by 128? Yeah.
Yep.
So we just see whether. So I see that it can be cut by 4 because it has a 4 times 2 and 4 times 4 and 4 times 3 and 2 and then 8 threes, and so it is 3/4. It appears to me 3/4 instead of 2/3. Why 2/3?
Oh, because I looked at it and I thought it would be like, since it was
Let's see. If I multiply 2/3, just a minute. Yeah, if 2/3 times 128. So if I see like this, oh, this is not a whole number. Why? Because 128 is not fully divisible by 3. So it would become something in fraction, in decimal something. So it is, while we have 96, so this is not 2/3. Do you see that or no?
yep.
Actually, to know what is this, you have to do, let me rub this because that's good that we are trying and understanding. So you can do any two number, take two consecutive numbers. Which one you want to take? Any two consecutive numbers.
Uh, 5 and 6.
No, no, in the sequence because we are,
Oh, 128. Just do the first two.
you want to take first two. Okay, so
Yeah.
you would divide the second one from the first one. I already did it. So it becomes
Yeah.
3/4. Let's take another so we are doubly sure.
96 and 72.
So what you have to divide by what? Is
Uh,
96 to be
s-
divided by 72 or 72?
no, 72 divided by 96.
And now if you see, oh, so you do like this, and normally we know we would see which what are the common d- factors. So if I see, you can, for example, see that 4 is a common factor. For example, 4 ones are 4 and 3 eights. So, and then I say 4 twos and 1 and 24. And there again, 6 times 3 and 6 times 4. So this is 3/4. Do you understand that? Like here. Or you can use your calculator even if you are confused.
Yep.
But so this means the equation is not 2 over 3, rather it is 3 over 4.
3/4.
And we would write and and we would say T1 is equal to what? Because
T T1 would be equal to 128.
yeah, that's so we define like this. This is your answer. Yeah? Are
Yep.
you somewhat clear now? Okay. So let me do another question, give you a question rather. And so let's do one more example. Let's say the sequence is 4, comma 9, comma 14, comma 19, comma 24, and so forth, so on. Can you tell me the sequence? Can you help me to write the sequence, please?
Tn plus 1 equals Tn
Tn plus 1 equals Tn.
plus 5.
Yeah. So if we see 4 plus 5 is 9, 9 plus 4, 4, and 9, yeah, Tn plus 5. Yeah. This is all okay. So you have rightly checked it that this is not a geometric sequence. Why? Sorry, it's not a geometric sequence. Why? Because 9 over 4 is something like 2.25. Yeah. And
Yep.
14 over 9 is 1.5 and 5 is continuous 5, 5, 5, 5. So they are, it's not a geometric sequence. In fact, it's a arithmetic sequence. Yeah. So we are good, right?
Yep.
Okay. Let's try to do a question and we try to understand that. Something where it has a um, real life example. Let's take a real life example and I would do it with your help. Let's say $400 is invested. $400 is invested in an account and it earns $20 interest a year. So it is invested in a bank, invested in a bank and earns $20 interest each year. Let's make try to understand. First of all, the first question. How much is the amount after 1 year, 2 year, 3 years, and 4 years? How much is the amount after 1, comma 2, 3, 4 years? So we are asked four answers, right? Can you
Yep.
help me with this? So I write solution. So initial value is how much?
Initial value is
What is the term one or so? Actually, we are doing like this. If you see, for, if I make rather, I just try to make a table maybe. I make a
term
table.
1 is 400.
Yeah, very nice. So I can do in another way, but you have understood very. So this is our T1 is 400. And then after 1 year would be this, which would be T2. This is for, yeah. So this would be actually T2 is after 1 year, right? So, so we can also do like this sometimes. We say this T0. T0 means the initial. This is T1. We can do like this in this case T3 and we have to find T2, T3 and T4. Do you see under what is meant by T2? 0. 0 means the first term which is starting. We can do that also. Sometimes it's more convenient. Does it make sense or it has confused you?
It makes sense.
Okay, let's see. So what would be T1 here if it is 400 and after 1 year, and we said it has a interest of each year $20.
Term one would be 420.
Yeah, 420. Then next year,
440.
yeah, 440. Next year, 460. And next year, 480. Right?
Yep.
Okay. Can you tell me what type of sequence this is now?
Uh, the arithmetic.
Yeah, arithmetic. And what is D now?
D is uh 20.
Yeah, 20. So if I make this, let's say, as a linear graph, it is at 400. Yeah,
Yep.
initially. Then it becomes 420. Then it becomes 440. Then it becomes 460. So if I draw it something like this, right? And if I write the equation of this, y is equal to mx plus c, can you help me to write this linear equation? Y, where y is actually the amount. So this is the amount. And what is on the x-axis? Year. Yeah? Does it make sense to you or no? So this is first year, second year, third year. Can you help me write this equation? Y is equal to
Y is equals uh
rise over run.
x
How much is the rise?
1 year, and it's 20
20 over 1. So what is m then?
so it's 1/20.
No, rise. Rise is not
Oh,
1 over 20. It's
20
rise
over 20.
20 over 1 because this is 1 year.
Yep.
So what can you help me to write the equation now? Y is equal to
20 20x plus 400.
very nice. So 400 is actually your C, and this actually we write like this. It could be written like amount A is equal to 20 T plus 400, where amount is in dollars, T is in year, and this is, yeah, A in dollars and T in year. Does it make sense to you?
Yep.
But normally, do you know that in the banks, do they give this type of interest, or they give you interest which is on the basis of um, compound interest? So, so normally, if we look at the same in another way, so normally the interest is given on a rate, maybe 10% or a 5%. If we say the same thing now, and we try to, let's say the same example, but we say example again. I just take a little more. So example, yeah, the amount, initial amount is again same, which is invested on. Initial amount is $400, right?
Yep.
Initial amount, $400. And now it is given on, let's say, 5% compound interest annual. 5% compound annual compound interest annually. Yes?
Yep.
Do you still remember how to do this, or should I do it?
Uh, so it's 5%.
So 400, the initial amount is. So after 1 year, what would be the amount?
Uh, 420.
Yeah, four, no, 400 plus 400 times 5 over 100 because 5%. So this total becomes 420. You are right. What about the next year?
Uh, Next year would be
Or you can write like this where in expression as I just wrote, and then we would find what is that.
400 plus 400
No, no,
times
no, no. The compound interest would take now
4
420.
420 plus
420
20 times
times,
5 over 10.
yeah, 5 over 100. Does it make sense to you?
Yep.
So this becomes, for example, you can use the calculator to let me know what is that. This 0 get cancelled with this 0. 5 1 is 5, 5 2s are 10, and this becomes 21. So now you have 441. Do you understand this?
Yep.
And what would be the next? So next year it would be 441 plus 441 times 5 over 100, right?
Yep.
And what is this amount equal to? Can you use the calculator to let me know?
I don't have the calculator
You
on.
don't have the calculator? Okay. So, okay, I just check it then. Otherwise, yeah. So, yeah. So 441 times 5 is equal to, so this becomes 441 plus 22.05, right? And if you
Yep.
add them, this becomes 364 point. So this is, yeah. So this becomes 400, 420, 441, and then it is 463.05. So you see, if you compare this with the previous one, it's type of something like going like this. So arithmetic sequence is actually like a exponential function. Do you understand this? Or should I explain it again?
Yep, I understand.
Okay. So normally it's compound interest is like an exponential function. Okay. If you see here, if we see this sequence 400, 420, oh sorry, this is not very clear. So let me take another color. And so if you see we have 400, 420, 441, and this was 463.05, right? Now we
Yep.
divide 420 divided by 400. If I divide that, so if I had 420 divided by 400, it gives me 1.05, 1.05, right?
Yep.
And now I divide 441. So I divide 441 by 420 divided by 420. It gives me again 1.05. Yeah. And I divide now 463.05. 463 463.05 divided by 441. That also give me 1.05. So what type of sequence this is then?
It's the geometric.
Yeah, can you help me to write the equation now for this? Tn plus 1 is equal to,
Tn plus 1 is equals to 1.05 Tn.
yeah, and right, T1 is equal to 400, which was our.
400.
And this is interesting. What you had a 5%. So 5% is 5 over 100. So you added it zero point zero 0.05. You understand why this is 1.05? Because we said initial amount. Let me, uh, I don't know. We had this at a 5%. You see here?
Yep,
So it means it becomes 1.05 every time. So therefore it becomes. Does it make sense to you or no?
it makes sense.
So, okay, I just stopped recording